Right, hello again. Now, if I want to have a look at the things like, I don't know, 2 times minus 4, things like that. Multiplication, mixing of plus positive numbers and negative numbers. Now, there is a specific rule here that if I can say, okay, what that means is that a positive number times a positive number equals a positive number. I mean, this is fairly trivial, really, because, 9 really equals plus 9. So, when we're saying plus times a plus, that's just really saying, something like 9 times 9 equals 81, i.e. a positive number times a positive number equals 81. I mean, that's nothing new. That's just fairly ordinary knowledge, but it's there for completeness. Now, I want to stress also what I've just said now, that what I've got here is a multiplication. Okay, 2 brackets together like that implies a multiplication. In general, I'm trying to move away from move away from this situation here. Really, I want to use an x as little as possible to indicate multiplication, because when we come to algebra, we commonly use x as a symbol for an unknown quantity. So we don't want to mix those x's up with the x's for the multiplication. I'd already given an indication of another form of indicating multiplication in the last lesson, where I just use a dot. Anyway, get back to what I'm talking about. A positive number times a positive number equals a positive number. That's fairly straightforward. If I have a negative number times a positive number, that becomes a negative number. It works the other way around as well. So when there's a mixture of signs like that, then the negative will always win out. And to complete the picture, a negative number times a negative number will produce a positive number. And when you think about it, that's probably the only sort of strange one here. I mean, look at these situations here. If I have, say, I don't know, minus £3, £3 overdraft in my bank, that would be equivalent to minus £3. And if I come along and say double that overdraft, then that just goes up to minus 6. So it's no surprise that if I have a negative number and I multiply it by a positive number, then a negative number will come out. The magnitude will be the same. By the magnitude, I mean I just consider the numbers without without considering the signs. The magnitude of this multiplication will be 6. I just need now to consider whether it's going to be a plus or a minus. And the rules here say that that's going to be a minus. That might seem logical. If I put it around the other way, I put a bracket here just to make it clearer. I don't want two symbols like that clashing, so I'll put a bracket around it to make it clearer. Now that might look a bit confusing, but the rule is that multiplication is commutative, so that means that I can turn it round. In ordinary multiplication, 2 times 3 equals 3 times 2. That's commutative. And likewise, addition is commutative as well. 2 plus 9 equals 9 plus 2. Things like subtraction and division are not commutative, but since multiplication is commutative, that is equal to that, and that just applies the same rules as I've just said now. So these two, when you think about it, are not really unusual. You can think of it that when you've got a clash of a negative number and a positive number, the negative sign will always win out. It's just this one here that you need to really remember as something new, possibly. A negative number times a negative number will give a positive number. Now, having said that, I need to want next to move on to square roots. Now, the square root of, say, 4 is 2. That's what you might learn in modern day, average life, if I can put it like that. But in mathematics, 4 has got 2 square roots. It's also got minus 2. I can indicate it like this. The square root of 4 equals plus or minus 2, i.e. plus 2 is the square root of 2, but also minus 2 is a square root as well. minus 2 times minus 2, it's that rule that I've just said. Minus times a minus equals a plus. So minus 2 times minus 2 is plus 4. So every number has got 2 square roots. That's what sometimes GCSE students miss out on, and thereby miss out on a mark. I've got to qualify that a bit. I should say that all positive numbers have got 2 square roots. If I go back to this original rule, if I've got a number is either going to be positive or negative. If I've got a positive number, multiplying it by itself will give it a positive number. If I've got a negative number, multiplying it by itself will give a positive number. So in that sense, because both those situations where you multiply a number by itself will give a positive number, a negative number cannot have a square root. So all positive numbers have got 2 square roots. Now, when we're manipulating these square roots, say I've got square root of 18, that can, by definition, is 9 times 2. Now, the rule, an extra rule that you need to know is that when you've got a situation like that, you still with me? I can split that off. That can become root 9 times root 2. Okay, so that's a rule to learn. It can obviously go the other way as well. If you've got a 2 square roots multiplied together, I can combine them into 1 square root. And you can see what happens here. The square root of 9 is just 3. So that becomes 3. I can't reduce that into a nice integer or anything, so I'll just write that down. Okay, so again, I've got a multiplication here. I've left the multiplication sign out completely here. But that still is a multiplication. It's 3 times the square root of 2. So that's simplified the square root of 18 down to this, 3 times the square root of 2. Oh, sorry, can you see that? Sorry if that was missing. Now, cube root of 8, for example, that would be denoted by that. Cube root of 8 would be 2, because 2 times 2 times 2 equals 8. Okay, 2 times 2 times 2 equals 8, so therefore 2 is the cube root of 8. Now, additional feature of this is that I can have the cube root of minus number here. That would be minus 2, because minus 2... Oh, sorry, I'm off the screen again. Minus 2 times minus 2 times minus 2 equals minus 8. To see this, I mean, you might be able to see this straight off. People come in at different levels, but if you can't see that straight off, you can do this in piecewise. I could just play around with these two for starters. What is minus 2 times minus 2? Well, that is plus 4. And I'll bring that down, minus 2. What is plus 4 times minus 2? Well, that's minus 8. So since that is correct, therefore my mistake. Okay, yeah. Therefore the cube root of minus 8 is minus 2. So you've got a bit of a situation is that all positive numbers have got 2 square roots, but negative numbers don't have any square roots at all. All numbers have 1 cube root, and that includes negative numbers as well. So you've got a slightly disjointed function. What I'd like to do here is take that on a bit more. This involves a bit of A-level maths here, but it's not too difficult. And along the way, it involves GCSE manipulations as well, so it's useful. what I want to form is a much more elegant for theory than that, using elegant in the mathematical way. I want a theory that says every number has got 2 square roots, every number has got 3 cube roots, and every number has got 4 fourth roots, and so on. And that would be a much more elegant mathematical theorem. But to do this, what I need to define an entity called I, which is defined as the square root of -1. The effect of that is that I squared is -1. So I is, I previously said that square roots of -1, the square roots of negative numbers don't exist. But I've said now that I've defined I to be the square root of -1, which is a bit funny. But if I square that, I squared, it just becomes a normal number, -1. Now, if I want to find the square root of a negative number, say -9, for example, then that would equal 9 times -1. Okay, if I can put it that way. It's -1 times 9, which is the same as 9 times -1. And this is where GCSE knowledge comes in. I can split that off, so it'll become -9 times, the square root of that will become the square root of 9 times the square root of -1. And I know the square root of 9 is 3, and I know that is that. So I've now defined the square root of -9 to be, my mistake again. Did you get what I was saying there? That the square root of 9 is 3, and the square root of that is, by definition up there, is I. So I've now got that the square root of -9 is 3i. So in that sense, I've recovered the idea now that, the square root of 9 is plus or minus 3. So that now means that I've got the square root of -9, and I've been able to derive 2 square roots for that. So with this extra bit of information, I'll be able to derive a theory that all numbers have got 2 square roots. What is the cube root of 1? Well, an obvious example from real life would be, when I say real life, I mean, the type of non-mathematical life, would be 1. 1 times 1 times 1 times 1 equals 1. So 1 is a cube root of 1. Now what I'm just going to tell you without proof is that another 2 cube roots would be given by this. Okay, so that's 2 numbers again. It's a -1/2 plus that, and it's -1/2 minus that. So that's those 2 numbers there, along with that, give you 3 cube roots for 1. So that's in line with what I'm trying to prove. Every number has got 2 square roots. Every number has got 3 cube roots. Every number has got 4 fourth roots, and so on. But I'll just leave it at that. The reason one of the reasons I've put that up is that there's always students who are more advanced, coming into GCSE. There's always some students who are more advanced than others, because I'm talking now, I've started off from the real sort of basic level of students who don't know anything at all. People who come in with a bit more knowledge might be a bit bored with what I've said up to now. So I'd normally say to them, okay, take that and cube it and see if you can get see if you get 1. And thereby prove that that is the cube root of 1. And then to cube that's within the realms of GCSE mathematics. All you need to know is that I equals square root of -1, therefore I squared equals -1. And with that extra bit of knowledge, you should be able to cube that and thereby get 1. I'm not saying that everyone now will be able to do it, but it's within the realms of GCSE mathematics to do that. So some more advanced students might like to have a go at that. So you know what I'm saying, that it involves, I might try that again, that situations where you've got a situation where it just involves GCSE mathematics really, but you need a bit of extra knowledge, but it really is just GCSE mathematics. So yeah, I'll leave it at that. It's just that the one important thing I need to stress from the level, from a GCSE level, is that at GCSE, or in mathematics in general, every positive number has got 2 square roots. And if you ignore that at GCSE mathematics level, you might lose a couple of points if you fail to take that into account. Right, so thanks very much again. Cheers for now.